Yeah, so I want to start out by a little background again. Now, Brian covered a lot of it already, but so the main reason why we're looking into switching to tokens at all is because, well, the X509 proxies were never really used outside of our community, and they were really invented by Globus, and as Brian said, the tool, they stopped supporting their software, and also it's harder to use than some technologies because it's at the SSL layer. That the user certificates have to be sent through there, and so not all software supported that. So instead, we're switching to these JSON web tokens and OpenID Connect, and they're widely used, and they're also potentially more secure because of that fine-grained control. And now, because we're using this standard, there's already a lot of existing tools that we can use with them, although we often do need some customizations, like side tokens. We had to write our own library for that, so it's kind of to enforce our particular claims of JWTs. And as I said, they're easier to use than SSL layer because it goes to the HTTP layer. However, that fine-grained control does make them more complicated to use if you take advantage of that, because you got to take narrow those tokens. And so this talk is focused on beyond the initial 3.6 OSG level, when we're thinking forward to when we're also wanting to use them to access storage and not just to start up jobs. And we found that when we started to look into that there weren't tools for that either. So we wrote some and intend to support it for the whole community. And that's what this talk is about. So I want to emphasize too that X509 host certificates are still all very important for this whole thing. We're not talking about changing that. The whole world uses those. It's just that the client certificates that we won't be using. So why did we choose Vault to manage this? So OAuth2 and OIDC, they're designed entirely for use in web browsers and web servers, but we're used to using the command line. We really depend on that. So we needed a server for that. And so after the initial web browser approval, OAuth2 will issue a refresh token that we can reuse indefinitely as long as we keep renewing it. So it has a high security value, so we want to protect that. And we also want to minimize the web browser interactions that users need to do to authorize things. Now, HTConda already had its solution for this before we started, but it doesn't easily support non-HTConda use cases. So it's like you have to get a token just for Condor. Well, what if you want to use it also to directly transfer files or other things? So we wanted something that was integrate with Condor, but not be only in Condor. And the available command line tool agent then that we started with, the OIDC agent, it's okay for the simple automated use cases for like submitting pilot jobs, but it's not user friendly enough for protecting the refresh tokens or the OIDC client credential and secrets, ID and secret. So we wanted a server-based solution analogous to MyProxy, where we stored user proxies in our old architecture. HashiCorp Vault was a popular open source generic secret store server, and it already had OIDC and Kerberos support, needed some additions, and it has a very flexible architecture where a plugin and it already had a nice API and flexible access policies, and an SSH agent authentication plugin also became available. And it issues its own tokens and then gives flexible access to different paths like a file system inside itself. It needed a configurator package, which htvault config, and then a command line client, which we call htget token, to control the flows. Now, this is the way a normal federated OIDC flow works, just without any command line. So just the user deals only with the user with the web browser and talks to the web server, and the web server redirects it to the token issuer to authenticate, and then from there to the identity provider and back. And then the refresh token and access token gets stored only in the web server and never even goes to the user browser. But with Vault and htget token, we kind of replace that web server with a server Vault and then the htget token client. And we keep the refresh token inside Vault and Vault gives a token to access itself, and that we do pass the access token on to the Vault client. But here's a little more detailed look at it on the token. So the first time through, when you don't have any tokens, you need to authenticate with your token issuer and an identity provider. Then what comes back is that we get from the token provider, then we've chosen a 3-hour access token and then a refresh token of 30 days. And then the refresh token stays in Vault, and we get a 7-day Vault token out, and an access token goes passed on and stored in the user node. Now, when the case comes in, let's say the access token is expired, but the Vault token isn't, then the HTGet token will use the Vault token it has, and then Vault will use its refresh token to talk to the token issuer to get a new access token. And at the same time, it gets a new refresh token go for another 30 days. So each time you use it, you get another 30 days. And then Vault sends back the new access token. And then in another case, when the Vault token is expired, we don't want to have to make the user go to the web browser again. So we're using Kerberos. You can also use SSH agent here. And then in that case, HTGet token will send the Kerberos token to Vault. Vault will give a new Vault token, and then it goes on with the rest of it like it did in case 1 to continue to get a new refresh token and access token. And then what happens if you don't use it for a month, then the refresh token expires and you got to go start over at the beginning at case 0. So HTGet token normally uses 3 files. It writes out 3 files. There's one thing is it calls a cred key. It's just an index, a user-specific index into a portion of the path in the Vault server where the refresh token is stored. And this information comes from the token issuer, and it gets stored in the user's home directory. And then the Vault token gets stored in /temp. We didn't want it in the home directory because it is sensitive for security, and don't really want it shared if there's a shared file server for the home directories. But also we don't need it to be in a per machine per session space. So we wanted to be able to be reused across login sessions. If you log out for the day, log back in, it'll still be there at least for a week. And then the third one is the access token. It gets stored in this XDG runtime dir. This is something that systemd manages, creates this little RAM space that everybody has, and it stays there until you log out. Until all your logout sessions will on one machine will be shared, but then they go away after you log out. And this is specified by the WLCG bearer token discovery standard to first store, to look for your bearer token there. So this is the output that you'd see if you run HTGet token. It's HTGet token and HDVault config are both packages available, RPMs and OSG. And in this example, I have set a command line option, a HTGet token option to tell it directly to run this script, this command to directly call out to my web browser. And then I also tell it not to use SSH in this case, just to simplify the example. So then the first thing it does is it tries to do OIDC authentication because there is no Vault token when it starts out. And then it goes to the web browser, and then I have to go enter in my web browser, the authentication, log in through my IDP, and then it stores the Vault token in /temp, stores the cred key in the home directory, and then it gets the bearer token and stores that in $XDG runtime dir. And in the first case, in case 1, then it is able to read the cred key from the home directory, so it knows where to store, and tries to use then the Vault token directly to Vault to get a new one. And then notice it tells you where in Vault it's storing it. It's got my cred key in there, and the role is the default role, and then it stores that bearer token. And then this is the case 2. Like if you don't have a Vault token, or if it's expired, then it's going to get the cred key, but then use Kerberos to get a new Vault token. And it stores the Vault token and also stores the bearer token. So, and the HT get token package comes with this HT token decode command, which understands the WOCG bearer token discovery to how to find that token and then prints it out and decodes it. And the -H option gives you a user human-friendly date on there. So in addition, HT get token and Vault have been integrated into HT Condor. And the way it works is when you do your Condor submit, you don't need to call HT get token yourself. It can be configured to automatically invoke HT get token as needed, and then store the Vault token in its Condor cred, which is the place where it stores credentials. And then the Vault token gets used by the Condor Credmon Vault, which is a plugin to Condor cred, and it repeatedly renews the short-lived access token. So then it just uses that Vault token and reads from Vault to get a new access token like every 20 minutes and pushes a new one to the job. The Vault token in this case is extra long. We use it to configure things. It sends the right HT get token options to get a 30-day token, and then stores that because jobs can last more than a week. And if you submit at the end of the week, then it might not make it till the end of the job lifetime. So they last longer. And then the submit file, I'll show more exactly what I mean here in another slide, but it specifies the issuer, an optional role, and then optionally can also choose reduced audience or scopes in the tokens. And it also may obtain more than one token for a job. And this implementation was already in the OAuth 2 credential support of HT Condor. And then the Vault token gets stored in Credmon Vault. Oh, even in /temp. In this case, instead of just being /temp VT, it also adds an extension of the VO and role. So when you're submitting to multiple Condor jobs, the multiple VOs or roles, you can store them all on the machine, the submit machine. So here's a picture of all the pieces that are involved in this complicated setup. So the user it just does Condor submit. This calls out to a plugin of it, which is called Condor Vault Store, which calls HT get token. And then when necessary, when it's the first time through, then the user is directed to go to their web browser and ends up, going to the Vault, which redirects it to the token issuer and to the identity provider. And finally gets back a Vault token, and then passes that 30-day Vault token on to Condor cred, and then Condor Credmon Vault gets to every 20 minutes use the Vault token to get a new access token. It passes it along to the user's job, where the user's job can use it to access data. The Condor configuration for the system administrator, it's pretty easy. They just need to install this Condor Credmon Vault RPM and set an option of where to find set the HT get token options and where to find the Vault server. And then the user submit server system, it says this OAuth with this _OAuth_ in the middle. Use _OAuth really is the part, use OAuth services, and then say which token issuers you want. And then you set also the which permissions, which is the scopes that you want, if you want it. Otherwise, it's going to take the default that Vault has set. But otherwise, if you want to reduce your scopes, you can set them in OAuth permissions. And if you started with the name of the issuer, and then if you want a specific audience to limit which servers can use this token. Then the service name then may also include a role involved, like CMS _production or Dune _production. That's the role involved. So you put that before the OAuth in the variable in your submit file. And then also handles may be appended to the end if you want to give more than one for a given role and an issuer to like say if you want to have one that's read only that includes some scopes, and if you want another one that you can use to write that includes different scopes, and then all those scopes will end up with those names in the end in Condor and $_Condor _creds in the job environment. then HT Vault config is our package for configuring Vault to work with HT-GET tokens. So it includes the extra Vault tokens and sorry, extra Vault plugins, and then a configuration generator. And then the configuration gets done through a series of YAML files where you can have multiple issuers in one Vault server, multiple roles per issuer, and for each role then maps to a configured set of scopes that can be requested for those roles. So the users don't necessarily need to have it in their submit files. And it supports the OIDC and Kerberos, like I said, and also the SSH agent authorization. And it also supports the high availability configurations, which was just built on native support that Vault had for any number of servers. So this supports having 3 servers, so that if any one of them is down, the other 2 can continue to supply service. And these are links to all the things I'm asking. I've been all the links to things that I'm been talking about. And are there any questions?
All right, thanks, Dave. Please feel free to raise your hand if you have any questions, and I will unmute you. Dave, one thing that come up in my mind as you're presenting, I know kind of you're driving a lot of this from Fermilab. Are there kind of any particular Fermilab use cases or users that you'd want to highlight that you think are really interesting that use the service right now?
Well, it's still all being set up, so we're in testing phases with the VOs. Yeah, it's not in production use yet. LIGO is farthest along, actually. LIGO is their cases are simpler, but they want it. They're closer to being in production mode. So yeah, so far it's really just LIGO and Fermilab that have embraced this quite a bit, but it's I expect that everybody's going to have this need, and that they're going to find that they're going to also, a lot of them are going to want to use this, a lot of VOs.
Yeah, so I see Steve Timms raise his hand, and then we'll probably cut the questions off there just so we can transition to Derek. Steve, I think I can unmute you.
Just briefly, I mean, doing that basic Fermilab has had quite a bit of work.
You got to speak up again, Steve.
Yeah, Steve, you're
working with it. You're giving me a second. Sorry.
I didn't quite get that. Sorry, Steve. Can you try again?
Anyway, doing this had good success with all the things we tried the HT-GET token server for. Our concern is not anything with the tokens, but how do we make the hybrid thing work for as long as we have to make it work? I think the token software itself is sound, and Vault in particular is sound. It's just a question of how are we going to survive with a tail of people on certificates for a couple of years yet. That's a nightmare I see, but it's just me.
Yeah, I think there's a couple strategies toward managing kind of hybrid submissions. That might actually be a great one for the discussion hour.